Okay, it's 1:30. I don't want to delay it, but let me mention I'm expecting my co-chair, Loa Anderson, to be joining. I did text him, and hopefully he will be able to join. So before I proceed, let me welcome everybody for joining the MPLS working group session for IETF 114. Your working group chairs for MPLS working group, myself, Tariq Saad, Loa Anderson, whom I'm expecting to join, and he did join now. We have Nick Lehman as well, but he's not able to join us today. Our secretary, Mac, has been very helpful in producing the report and other things, Mac Chen. And a reminder to everyone that this session is being recorded. Before I flip to the next slide, I know that Loa wanted to give a couple of words, and he's already raised his hand, so I'll give him the stage to proceed. Please go ahead.
Okay, thank you, Tariq. I have had a short discussion with David Sinnekrop and Andy Mpls over the last 2 days, I think. And we've been discussing the 25-year anniversary of the MPLS working group. So I have a little bit of history. So prior to November 1996, there was a lot of kind of unorganized work or work organized by different companies. But November 6, 1996, we had the first, what we call the tag switching BOF at MIT in Boston. And that was followed by that first BOF in MIT was outside the IETF meeting. We planned a new BOF at the IETF meeting in San Jose in April 1997. But what happened was that Joel Halpern, that was the responsible AD at that time, he beat us to the goal line, and he actually chartered the MPLS working group in March 1997. And the meeting we had in San Jose was kind of a mix between a BOF and a normal working group meeting. As I remember it, Vijay and George were sharing, and I was a note taker, and Ross Callan, Eric Rosen, I think Jakob had presentations. The very first meeting that actually was a meeting that was run like a IETF working group meeting should be run, was run in the IETF in Munich, and it took place Wednesday, August the 13th. So that was all the things that people requested slot, people made presentations that wasn't kind of company sponsored and things like that. So I think we could actually, if we want, we could consider August 15th, 1997 as our birthday. And it actually, that day is actually corresponding to the meeting in the summer. So it's Wednesday tomorrow. So we can say that we made 25 years and we are going strongly into the next, whatever it will be, 25 years. Okay, that was it. Thanks. I will send out a mail with what I just said.
Okay, thank you, Loa. I'm very proud to see MPLS has made it to the 25-year tick mark, and I want to wish it another 50 or maybe 100 years.
Yeah.
Okay. I'll have to run a little bit faster. So let me progress to the next slide. And unless I still see you raising your hand, Loa, but let me know if you
No,
want me to.
that's a mistake. Wait.
Okay.
Yes,
So this is the usual time where we present the Note well, which many may already have been acquainted, but for those who don't know about it, please, you're encouraged to read the best current practices about contributions and participation at IETF. So please go through it if you haven't done that already. A bit of administrative pointers. We do have an MPLS working group wiki. We encourage you to visit that. It has informative information about the activities that the working group is working on. We also have a GitHub page, so we do once in a while use it, and we plan to continue to use that. We have a decent agenda with 6 items today, including the intro by the chairs. I am hoping that people who have not submitted their slides have the slides ready. So when time comes, I can give them the ball for them to share their slides. So those who who have not uploaded the slides know themselves. We do have 2 erratas reported since last time we met. The first one is pretty straightforward. I think the authors dropped the RRO IPv6 sub-object from the sentence, although they meant to say 2 flags. So I think this has been taken care of by our AD, and it's an accepted errata. The next errata is against RFC 3031. There is a claim that usage of the abbreviation L1, L2, and L3 may be confused with, for labels, MPLS labels, may be confused with layer 1, 2, and 3. Discussed that with my co-chairs, and we did agree that with 25 years, or I'm not sure how many years for RFC 3031, it's been alive, and people are by now very well acquainted with what L1, L2, L3 means in the context of RFC 3031. So this is not too much of an issue. I do want to flag in terms of document status update, and since last time we met, we do have 1 RFC, and we thank all the working group and the authors who contributed on this to make it an RFC. We have an RFC which is stuck in misref right now, and I checked the misref pointer. It's pointing to a draft that is expired. I'm not sure if there is a co-author present that want to comment on that, but I know the main author is away, so we'll have to follow up on that. And feel free, Loa, to intervene if you know of an update on that. In terms of new working group documents, so the working group was active the past period, and we have 4 documents that got adopted. Thank you to the working group and the co-authors. I'll quickly skim through the documents, and before I do that, let me give Loa a chance to comment.
So concerning the document, the SFL control, we have appointed Max Chen as the shepherd, and he will actually submit or he start writing the shepherd's write-up as soon as Stuart reposts the draft, because it's expired.
Yep. Okay, thank you. Okay, I'll quickly skim through the documents. We left the status for people to review offline, and some of the drafts are on today's agenda. We also left a summary of the report for the MPLS Open Design Team activities, and that we talked about in the previous session, the joint session with PALS. I'm not going to go through it today because we already went through it, but people are encouraged to do that offline if they need to. So with that, I can switch to the first presentation for today. And I think it is Rakesh that I'm after. And I can give you control if I can see you in the list. Interesting. I don't see Rakesh. Oh, I see him. Okay. Rakesh, can you come to the mic if you can hear us? Oh, okay. I see you. I guess I can flip the slides for you if you want to use the video. I'm fine either
Hi,
way.
Tarek, you hear me?
Yes, I can hear you. Yeah,
Yeah, so appreciate if you can flip the slides. Thanks, Tarek.
I'll do that. No problem.
So hi everyone, my name is Rakesh Gandhi and presenting the draft on the MPLS IOM on behalf of the co-authors listed. Next slide, please. Next slide, please. So agenda is quite simple, requirements and scope, the summary and the next step. Next slide, please. So requirements and the scope of this draft basically is to transport the IOM data fields with MPLS encapsulation. So in scope is the work that's being done in the IPPM working group. So the first draft, the IOM data is in RFC now. I think it's RFC 9197, I believe. Then the next one is for direct export. But irrespective of the data fields, here the scope is on the encoding or NCAP on the MPLS side and cover both the edge to edge as well as the hop by hop IOM cases. Next slide, please. So draft has been around for a few years now. Used to be in spring, it was moved to MPLS. About a year and a half ago, we had MPLS RT expert review. We received good comments, including the gas channel for IOM. And this was just before the M&A work that got started. Since then, the encoding of the NCAP has changed a few times. This one is the latest encoding that's in the DraftJax MPLS M&A header. So we'll just review that encoding today. Next slide, please. So the M&A indicators basically as defined in the JAX draft this morning that was presented in PALS. There is a bit, a flag in the TTL in the next LSC after the M&A label, which is the a special purpose label that indicates that there is post-tech data present. And if there is a need to process it hop by hop, then there is another flag for it. Next slide, please. So as mentioned, there are two flags defined in the TTL field. And in case of end-to-end IOM, there are option types that's defined for that in the IPPM documents are applicable. And for hop by hop, there are also option types defined for that are applicable in these two cases. Next slide, please. So as mentioned, as part of the MPLS RT expert review, suggestion was to use IOAM gas channel to carry the IOAM option types. So this is the encoding. It would look like basically all IAM data fields with the header that's defined. Next slide, please. So the complete packet with encoding defined in this draft, there is an M&A label, the special purpose label. In the next LSC, there are two flags defined in TTL and post-tech data, basically the IOM data fields. Next slide, please. So the procedure-wise, the NCAP node will add the IOM data, the option type, and the indicators, so which is the M&A label and the flags. In case of edge-to-edge, there's a flag, PNI flag. Because the hop-by-hop flag is not set in the M&A, the intermediate nodes will skip the IOM processing. And as is the case with M&A, the M&A header needs to be received by the DCAP node that contains those flags in the header. And basically, DCAP node will process the IOM. It may point the data, IOM data to the slow path, and it will remove the IOM data fields and the M&A header. Next slide, please. So only difference in hop-by-hop case is that there is a new flag set for it, and the intermediate nodes will see it, and it will process the IOM data from the post-tech data option types. Next slide, please. So next steps, basically welcome your comments and suggestions. There is some good feedback for the MPLS extension header draft that Hayu presented this morning. So we do have a gas-based post-tech data defined. It probably makes sense to use the extension header as a common header, assuming that's what the working group consensus or acceptance is. This can be done as part of the working group process. But if you have any feedback and suggestion on that, please let us know. And in the end, we are requesting a working group adoption for this draft. I think that's all I had. Thanks.
Thank you.
Comments.
Thank you, Rakesh. Yes, we have Greg in the queue. Go ahead, Greg.
I would not tell you what he did, but because it will be embarrassing to me. Okay, so I have a couple questions. First, RFC 5586 defines GACH for only to be used on OEM packets, so it's not to be used on the data packets. So that makes it problematic of applying IAM to the data packets, which is, I understand it, the intention. Second of all, I have a question. So you suggest to support all trace options defined in IAM data draft, incremental and pre-allocated. So you know that pre-allocated, it's basically when each transit node adds data to the packet. I think that's a very serious impact on performance, and I would be very much concerned about that to be supported in Mpls. I believe that it's not useful option for Mpls. So maybe in some other environments it's useful, but in Mpls especially, since it's beneficial but not required option, so it's something that concerns me. And second of all, your request to working group adoption is not clear because you're proposing a particular encapsulation which cannot be used on data packets. So that makes this solution that you are proposing not realizable.
Yes. So the you hear me? No.
I can hear you, but probably people.
Yeah, we can hear you on the line as well. So go ahead, Rakesh. Now we can hear you for sure.
Okay. It's better. Thanks, Greg, for the feedbacks. So GSCH recommendation came from the MPLS RT expert. I do agree that in 5586 it's mentioned it's not for the probe or for the data traffic that IOM being used. So there is we mentioned in the draft that this is an issue, and if you recommend or if you think that the high-use draft, the extension header, is the right approach for post-tech data encoding, then that is one suggestion that we could take as a next step.
Yes, thank you. I don't know what the community will decide which solution to accept and standardize. I hope that we'll decide to standardize single solution. Which one it will be, it's yet to discuss. But yes, I think that since IAM is one of the use cases for M&A in the document that working group adopted, I hope that it will use their solution that working group adopt for M&A.
Yeah, and currently, as you know, there is only one proposal. That's the high draft for post-tech data encoding, and that seems to be good. It's not controversial, so at least at this point, unless there's another proposal comes, it's like a right next step. But, welcome the suggestions.
Okay, my understanding of proposed solutions is different, but if the working group already converges on how you proposal for post-tech data encapsulation, it's very good news.
Okay. Yeah. Thanks, Greg.
Thank you. I am next in the queue. My question hopefully is very quick, Rakesh. Is there any additional validation that the Ingress will have to do before triggering this action, be it edge-to-edge or hop-by-hop, like capability check? Specifically the edge-to-edge, does it have to check if the egress is capable of processing the extra header or even the action timestamping? Thanks.
Yeah, definitely. There is a capability signaling is required from egress, and if hop by hop, then hop by hop as well. And this is either part of the M&A capability signaling, or there is also quite a bit of work going on with iFeed and other PCE-based signaling as well for that capability. But yeah, there is definitely, to avoid dropping the packets, we do need the capability signaling.
Thank you. I don't see anyone else in the queue. So thank you, Rakesh. I'll move on.
Yeah, thank you.
Thank you. Next I have is Mankamana on Mpls MLDP extensions for multi-topology routing.
Good afternoon. I think we can go to the next slide.
Okay, one moment.
You guys can hear? Okay.
Yeah, I can hear you, Mankamana. Thank you.
Sure. So just to give a little background, that this draft we presented in IETF 111, and it has been adopted very recently. And this draft has been, in fact, implemented and deployed. And I think there were some comments which we wanted to kind of bring out here. We can go to the next slide. So one of the comment was how to handle reserved bits, and initially we had written it as a should be 0, and the comment from working group was make it as a must be zeroed on transmission and ignored on the receipt side. And I think that is fair enough. And unless anyone has any other option about this. I think we are okay with that. Yeah, we can go to the next slide. Another comment was about can we make it as a two draft where MLDP extension for IGPs, which is like IT empty field, is separate, and for flex algo it is separate. But I don't think we don't think that may be a good option or really needed, because there may not be a deployment where you really want to have empty as well as on top of it flex algo. So you will be using either of them, and maybe that was the reason. I don't have historical reason 10 years back why it started with two different draft and then we finally decided to merge it. So I think we would like to go with the way it is currently implemented and the way the draft is. So that's all. And I would like working group to provide comment. And I think by the next IETF, we would like to go for working group last call, considering it is implemented, unless there is some more comment or some more discussion which is required.
We have Loa in the queue, and go ahead, Loa.
So it's Loa. Why are you waiting to the next meeting?
I'm just waiting in case people have some comment. Otherwise, from our side, from the author side, we are okay for last call.
Let's say they have to give you a comments on October 1st, and then we go ahead. We don't need to tie this to a meeting.
Okay, yeah, sure. So we are ready for last call for this draft.
Okay, yeah, okay. Just send out a mail and say that we will ask for starting the publication procedure after
Sure.
October 1st. But you
Okay.
send out a mail.
Thank you.
Okay, we don't have anyone else in the queue. So thank you, Mankamana. I'll move on. And I have the next one is deprecating the use of route alert in LSP ping, and the presenter is Kiriti. I don't see your slides in the list to be shared, Kiriti, so let me see if you're available. Let me start by asking Kiriti if he has any slides to share, or how does he want to tackle that? I do see you walking to the mic, so please go ahead.
So I'm at the mic. So I do not have slides. I was hoping that maybe Ron had uploaded the slides. I can give an update of where, closer? Okay. So I can give an update of where we stand with respect to this. In the document, in the LSP ping document, we had several modes. And one of the modes is that we want to be able to return the ping, the reply via control channel. And it's not clear at the time why we did that. I think there was some concern that if you return it over another LSP or something, and you're debugging LSPs, that would be a problem. So we introduced that mode, and then we said, oh, to make sure that happens, let's make the packet go up to the control plane at every hop. So that's one use of router alert. The other was to make sure that the reply or the original message doesn't make it past the end of the MPLS domain and somehow get injected into traffic outside of that. And we have several ways of doing that, so we don't need to do router alert for that. One point was brought out that so the way we do that is we set the destination address in IPv4 to 127 slash, I'm trying to think, 8, 127.0.0 slash, no, 127 slash 8. And unfortunately, in IPv6, there is not a whole subnet that you can use similarly. There's a single address, I think it's ::1, which is something that Greg had pointed out. So that's a little bit of a restriction, but at the same time, you know, we set the TTL to 1, we set a bunch of things so that the packet won't, you know, go beyond the last MPLS router. And so the idea was, let's just deprecate router alert. And that's a direction that IPv6 guys want to go, independent of you know, what we're doing here for LSP ping. So modulo this one comment, I think this draft is ready to go in terms of, you know, at least to do a working group adoption. And then, you know, if we have to iron out a few things, okay. But then, you know, we want to get to the next level where we say this is, you know, that whole approach of having a router alert in LSP ping packets should go away. And of course, between the working group adoption call and working group last call, we need to make sure that no one's actually using this. And that's our feeling. But, you know, I think we need to give people time to say, have they actually implemented LSP ping with router alert? So that's basically where this draft stands. And I'm sorry I don't have slides, but that's a summary of this.
Okay, thank you, Kiriti. We have people in the queue for asking questions. And let me ask Loa to go ahead.
So, hello, Kiriti. Actually, the point with this draft is that you presented it once before, and you were asking for a working group adoption, and we didn't have one single reaction on the mailing list. So your task is to actually make sure that you have a discussion to actually motivate, make it the working group document. Thanks.
Okay. I mean, we can start a thread, so we'll do that.
Yeah, please do.
Okay.
Okay.
Zafar, you're next.
Yeah, this is Zafar Ali. So you mentioned that the IPv6 group is also going in that direction. Could you elaborate a little bit more? Because I think there is an individual draft, but no discussion. I could be wrong on that.
So I don't know the details of what's happening in IPv6, but there was a movement in the IPv6 6-man?
It was 6-man. 6-man.
Yeah, saying, you know, we want to get rid of router alert. And I think in general, they want to make sure that the extension headers that are being used are ones that, you know, actually are being used and will go forward. So I'm not a regular attendee of 6-man. So that's more of a side comment. I mean, whatever we decide here will have some influence there. But, you know, really, if we are not using it, whatever 6-man is doing, if nobody has implemented LSP ping with the router alert option, either in v4 or v6, we should just take it out of the document.
Yeah, let's have the discussion on the mailing list, but you mentioned about the survey. I think the survey will be important. Thank you.
Thank you. Greg, you're next. Thanks.
I'm Greg Mirsky Erickson. As Kiriti pointed out, so there is a problem with the IPv6 address being documented in LSP ping. And I think that we might use this work. It doesn't have to be due as an individual draft, but in the course of the progressing it to publication, to fix this problem and then fix a recommendation that basically suggests to use destination address as an entropy. But instead of that, given the fact we have single address in IPv6 for the loopback, recommend use the source UDP port number as an entropy. but it's something for discussion. Thank you.
Yeah, thank you.
Okay. No one else in the queue, so thank you, Kiriti. But I'll double check. I think you are next still, so please stand the ground and I'll switch the slides.
Okay, yeah, thanks. So, so let me switch to this one. In this document, we've proposed a registry, an IANA registry for what we are calling the MPLS first nibble, which is the first 4 bits after the last label, the label with end of stack bit set. So we're up to revision 02 here, and this is joint work with Stuart Bryant, Matthew Bocci, Greg Mirsky, and Lo Anderson. Next. So there's been quite a bit of discussion on this, not so much on the open MPLS list, but in the design team. And I think there was some concern, is this trying to replicate the IPv4 version number registry? You know, what is the goal here? And the goal here is to say, we've had a couple of code points that we've put that we use for example, the pseudowire control word or the DetNet control word or the beer header. And we just said, okay, we'll use 0 for this. We actually use 0 for both pseudowire control word and DetNet control word. And then we use, I forget what, 2 or 1 or 2 for the beer header. But these are sort of just allocated. And basically, everyone just says, avoid 4 and 6, and then you're good. But I think it's a lot clearer if you have a registry. So we're looking at these control words and the beer header as early instances of what we are now calling post-stack data. And so we're saying it would be good to have a registry where we have all of this. So that kind of answers the question, why a registry? The other part that there was some confusion is, does this registry mimic the IP version registry? And the answer is very clearly no. We avoid 4 and 6, but if tomorrow there's an IP version 7, the PSD could also have version, this first nibble registry could also have an entry for 7. And if you follow the recommendations in the document, there will not be confusion between IP version 7 packets and post-stack data. So the recommendation here is you can send a packet that's a native IPv4 or a native IPv6 packet without PSD. Any other packet must have some form of post-stack data. In other words, there are existing RFCs that say you must have, for Ethernet pseudowires, you must have a control word. The idea there being you don't confuse that Ethernet packet with an IPv4 packet. So that's sort of the third point here. We want to mandate a PSD or a control word or something that doesn't start with 4 and 6 for all non-IP, actually more accurately, all non-IPv4 or IPv6 packets. Now, can we mandate this? We already have an RFC that says, at least for Ethernet pseudowires, that you must have it. But you can't mandate it in the sense there are implementations that don't do this. You can wrap them across the knuckles, you can do various things. The providers who have this should understand that they're opening themselves up to packet reordering and other kinds of trouble. But, you know, all we can do is set the rules and people can decide whether they want to follow them or not. The other thing, the last one that's a bit more controversial is, should the fact that there is PSD in the packet be in the control plane? So for example, with pseudowires, you say in the control plane whether you're going to insert a control word or not, or should be in the data plane. And so many of the M&A proposals say there's a bit in, the moral equivalent of the FAI special purpose label that says there is PSD in the packet? Or should it be both? And I think Stuart put it in this way, that he doesn't like the belt and suspenders approach. I think that's something that the working group should decide. That there is signaling in the control plane, but maybe it's nice to also have signaling or an indicator in the data plane, so that when you're parsing it, you don't make a mistake. So these are the sort of open points. Next slide. So I think that discussion that we had, and some of it was pretty vigorous in the design team, needs to happen in the Mpls working group at large. But I think the questions to ask are, is this stuff useful? But does it belong in the IETF? Does it belong in Mpls? And then, is this a good enough starting point for working group adoption? I mean, there's definitely a lot of things to fill in and to clarify. But are we at a position that we should do working group adoption, or should we have more discussion in the mailing list? That's kind of where we are. And I think that's the last slide.
Okay.
Tarek?
Yeah, I have a question, please. So with signaling, it's a little bit, I understand if you signal in advance, I will be sending you a control word, and then you start sending traffic after, and that's a kind of a static state that you're in, that all your flow or all your packets from ingress to egress will contain the control word, and that's understandable. But when you're doing on-demand type of thing, where you enable, you're saying here a control word. I can give a different example. You enable something, but then your flow is already started. So some packets may carry that, or some packets may not. And there will be a timing issue between control plane and the data packets. So we cannot correlate when the state is ready for control word being present at that time. So I'm not sure. The signaling. I mean, there is advantages in carrying it in the data plane in that sense. Do you agree?
The BR guys do that as well. So even though they have a lot of signaling in the control plane, in the data plane they have a special purpose label that says, I have a beer data which comes after the stack. So basically they have BRPSD, but that's heralded by a special purpose label. So we do both. Like the control words for DetNet and pseudowires are signaled in the control plane, but not the data plane. In BR, we do both. And then, as you said, there may be cases where it's more ad hoc. And so you'll have things that are signaled in the data plane, but not in the control plane. So I think that's something that we need to think about and see from an implementation point of view, as well as make sure we're doing the right thing with the packets point of view. What is the approach we want to take?
Okay. There isn't any other question. So I will move on. And thank you, Kiriti.
Okay.
I think the last presentation for today. So I do have, I think, either Robin or Shuang-Long.
I will share. Okay.
Okay. Do you want control to flip between slides? I've given you.
Don't need. You can control it. Okay. Hello everyone. My name is Shuang-Long Chen from Huawei. And today my topic is generalized IPv6 tunnel for Mpls. Next slide, please. Okay, we know some technical challenges to Mpls. First one is the MPS lacks the mechanism of source unification for MP2P connections. This causes the difficulty and complexity for OM or MPS. We know that also the SFL is defined, but few implementation. And the second, the type of payload cannot be directly determined because no payload type indication. And then the third, we know the MPS is difficult to encapsulate new forwarding attributes for the new features, such as the net slicing, F8, and APN, and so on. The fourth, the process of the ESMP function is complexity. We know the entropy label or flow label are usually placed at the bottom of the label stack for processing. And the internal IP header information may also be passed for the purpose of the ESMP. Okay, next slide, please.
Before I progress from along, would you like to take questions now or towards the end? Do you like to take the...
Pardon, sorry.
I have Greg wants to ask a question. Do you like to take it now or towards the end? Do you like to take the question?
Oh, sorry, my network was unstable.
Okay, I see Greg already at the mic. Why don't you go ahead, Greg, and ask your questions?
Okay, thank you. Can you clarify what you see as the difficulty complexity of OAM over MPLS, if I understand correctly, for the multi-point-to-point connection?
I mean, maybe in the next slides, I can give them more detailed information. Okay.
Okay, are you okay to hold, Greg?
Okay, I can hold.
Okay,
thank you.
Thank you. Well, please proceed.
Okay. So next slide. Okay.
Number 3.
Okay. And in the draft, the GIP6, the draft defines the GIP6 tunnel how to support the new features, for example, IOM and APN, and the existing functions for the IP tunnels based on the extensions to the IPv6 extension headers. The right figure is showing the encapsulation of GIP6. In this figure, we can find the IPv6 extension header includes the encapsulations of new features and encapsulations of existing IP tunnels functions. This is the GIP6, the encapsulation. If the GIP6 tunnel is used for MPS, there can be the following advantages. First is the IPv6 source address is used to form a source identifier. And the second, the IPv6 net header can indicate the payload type. And the third is the IPv6 flow label are used for the ESMP. And the last one is the encapsulations for the new features have been defined well in the IPv6 and can be reused easily. Next slide, please. Okay. And in order to support the MPS based on the GIP tunnel, the method to carry MS label stick information is defined as follows. Special or well-known IPv6 prefix need to be assigned and then encapsulation the MS label. And the second is the IPv6 special prefix can be followed by multiple the MPLS label encapsulations to form a 128 bits. We call it the IPv6 MPLS seed type 1. This is the following figure shows the detailed format. Okay, next slide, please. Okay, the IPv6 MPLS seed can be placed in the IPv6 destination address, and how to process the first label when a packet is received. See this figure. If the local action of the label 1 is pop, then pop label 1 and label 2, label 3 are moved left by 32 bits. If local action of label 1 is swipe, then replace the label 1 with a new label. Yeah, next slide, please. Okay, if all the MPLS labels tag cannot be placed in the IPv6 destination address, IPv6 root header can be used to host the remaining MPLS label stick. In this figure is defined IPv6 MPLS seed. We call it type 2, and contains multiple label encapsulations. The type 2 MPLS seed is used as the segment in the root header. After all of the label encapsulations in the IPv6 destination address are copied, the first label in the segment indicated by the SL will be processed. Yeah, next, please. Some considerations about the control plan. The first one is the JP6 only provides a way to carry MPLS label encapsulations in the data plan. And the MPLS control plan doesn't need to be changed. So MPLS label can still be distributed using existing control plan. Doesn't change anything. Okay, next, please. This all. Any comments? I welcome. Thank you.
Yes, Greg is at the top of the queue.
Okay, thank you. Okay, now I have two clarification questions. The first is to the first slide where you mentioned that motivation for this work is difficulty and complexity on using Mpls OAM. And second is how, in your opinion, this work is related to Mpls over UDP RFC 7510 and Mpls, SR Mpls over IP RFC 8663.
Sorry, my network is not stable. I can't listen very clear. And Jamie, can you help clarify it for me? Okay, Jamie.
Jimmy, do you want to take that question?
Yeah, I can try to help to answer that one. So I think the complexity about the OEM for MPLS is mainly due to the lack of the source node indication in the MPLS package. So that is the issue document is talking about. As for the MPLS over IP and UDP encapsulation, my understanding it is a separate thing from the MPLS original MPLS encapsulation. So we are comparing the MPLS encapsulation with this new proposal here.
Okay, I'm a little bit confused that you say that MPLS OEM packet don't have source information, because if we use IP UDP encapsulation for OEM packets, as we discussed earlier, for example, in LSP ping, so it doesn't include IP source address.
Yeah, that is another encapsulation which may help to encapsulate the source address, but the MPLS itself does not have this kind of capability.
Yes, but it's a matter of choice. So basically, yes, if you choose, then you can use SFL again. So that's already been solved. So if you choose non-IP encapsulation, then you can use SFL, and SFL, so synonymous flow label, being developed as a mechanism to identify the source in MPLS environment.
Yeah, that one has also been mentioned in the presentation. You can see SFL is one option. It is not widely implemented or used in the network.
Okay, but we already have defined, and then you introduce another option that is not being implemented by anybody yet. Kind of strange. Thank you.
Okay, Greg, please follow up on the mailing list as well. So I'm next in the queue. Tariq Saad as a working group participant. As you know, the MPLS label contains, in addition to the label value, TTL and the traffic class fields, and the IP header as well. The IPv6 in this case contains the traffic class and TTL. So which ones will be respected in your encoding proposal if they're contradictory or different? So which is it, the IPv6 TTL and traffic class, or the MPLS?
Hello, Tariq. Can I take this question?
Yeah, sure.
Okay, Tariq. I think that's a very good question. In fact, this has been taken into account. Until now, we think that in order to maintain the original MPLS encapsulation, we recommend that the MPLS TTL traffic class will be used instead of the IPv6 TTL or the traffic class. That's the answer until now. But we thinking maybe in the future, if possible, maybe we only encapsulate the label value, but the IPv6 TTL and traffic class can be reused. But I think that means much change.
Thank you, Robin. I was hinting to that, maybe you should consider only the label value rather than the whole 32 bits. But the next question I have is, why do you call it SID? Is it SRv6 related?
In fact, yes. In fact, it's not IPv6 address. But you know that we talk about some of this generalized SRv6. I mean, this is the segment that encapsulate the MPLS label. So we call it a type of this SID, maybe more appropriate. That's some thinking.
Okay. So it is SRv6 then?
To some extent, the generalized SRv6, because you know that the classic SRv6 is the segment means the locator plus the function plus arguments. But here is different from the classic SRv6 segment.
Okay, I appreciate maybe you clarify that in the draft as well.
Okay, fine.
Okay. I don't know. Okay, I don't see.
Sorry.
AC, you want to ask a question?
I was just gonna say, I think you should change, along with what you said, I think I was thinking the same thing. You should change the name of the draft even. Shouldn't just clarify it.
I agree.
Okay, maybe.
Okay, thank you, AC. Was there another question you had? No? Okay, that's it. That's it, and we're right on time. Thank you so much, the presenters, and this was our last presentation for today. Again, thank you for joining and contributing to the working group. Looking forward to IETF 115. Thank you. Loa, if you want to say any closing remarks, go ahead.
No, I'm fine. I think next time is London. It might be possible to travel even for me. See you in London. Bye.
Bye.
Right, so now I got it. I hear you had your own amount of fun. When I was in secondary.
You had direct flight, right?